Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll solve a problem based on the concepts of ellipse. As per the problem, identify the conic and find its foci and vertices. We are given the equation x squared equals 4y minus 2y squared. We have to identify the conic section represented by this equation. We should write this equation in general form. We should move the negative 2y squared and 4y to the left side of the equation so that we have just a 0 on the right side of the equation. We get x squared plus 2y squared minus 4y equals 0. This is the given equation in general form. Now we can identify the conic represented by this equation. In this equation, as you can see, there is a square on both x and y. So this equation does not represent a parabola. Also, we can see that both x squared and y squared terms are positive. So this equation does not represent a hyperbola. The coefficient of x squared is 1, the coefficient of y squared is 2. Since these coefficients are not the same, that means this equation does not represent a circle. This equation represents an ellipse because there is a square on both x and y. Both x squared and y squared terms are positive and their coefficients are not the same. So this equation represents an ellipse. Now we can find the foci and vertices of the ellipse. For that we should write the equation of the ellipse in standard form. We can use complete the square method to write the equation in standard form. We should change the equation in general form to standard form. In this equation, there is only one x term, x squared. We can write x squared as x minus 0 squared. For y terms, we have to use complete the square method. The first step is to factor out the coefficient of y squared from both y terms. So we should factor out 2 from both terms. I get y squared minus 2y. In the expression in the parentheses, the coefficient of y is negative 2. We should divide negative 2 by 2, which is equal to negative 1. We should add and subtract square of negative 1 in the parentheses. I get next we should move minus negative 1 square outside the parentheses. And when we do that, we should multiply it by 2 because 2 is to be multiplied to all terms in the parentheses. Next, we can complete the square in the second parentheses. We should write it as y and then the term that is being squared, which is negative 1. So we get y minus 1 and then we put the square outside the parentheses. And next we evaluate negative 1 squared, which is equal to positive 1. 1 times 2 is 2. So we get minus 2 equals 0. Next we should move minus 2 to the right side of the equation. because in the equation of ellipse in standard form, the constant term is on the right side of the equation. So we should add 2 to both sides. Next, we should get rid of the 2, that's with y minus 1 square. So we should divide each term in this equation by 2. Two divided by 2 is equal to 1. In this equation, the denominator of y minus 1 square is 1. So we can write this equation as this is the equation of the ellipse in standard form. As we can see in this equation, the number in the denominator of the x fraction is 2. The number in the denominator of the y fraction is 1. Since the denominator of the x fraction is greater than the denominator of the y fraction, that means this ellipse is wider than taller. The general equation of an ellipse in standard form that is wider than taller is x minus h square over a square plus y minus k square over b square equals 1. We can compare our equation with this general equation to find the values of h, k, a square and b square. We can see that h is equal to 0, k is equal to 1, a square is equal to 2, and b square is equal to 1. We can use these values to find the foci and the vertices. Let's start with the foci. Foci of an ellipse that's wider than taller is h plus minus c, comma k. We can find the value of c from the equation c square equals a square minus b square. We can sub in the values. I get c equals 1. The value of c is always positive. So the foci of this ellipse are 0, which is the h value, plus minus 1, comma 1. 0 plus minus 1 is equal to just plus minus 1. So the two foci of the ellipse are 1, comma 1 and negative 1, comma 1. Next, we can find the vertices of this ellipse. The setup for vertices of an ellipse that is wider than taller is h plus minus a, comma k. We found out that a square is equal to 2. So the value of a is equal to square root 2. We apply square root to both sides. Therefore, the vertices of this ellipse are 0 plus minus square root 2, comma 1. 0 plus minus square root 2 is equal to just plus minus square root 2, comma 1. So the two vertices of this ellipse are square root 2, comma 1 and negative square root 2, comma 1. So these are the vertices of this ellipse. This should be the final answer for this problem. So these are the steps you have to keep in mind to solve this problem. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.